let's begin with the topic common laboratory glassware. Labware, most of the labware generally made up of two type of material. One of them is plastic and another one is glass. Plastic is inexpensive and disposable, but it can't be heated on hot plate or burner, and it may be reactive or contaminate the sample. That's why we generally use less reactive glass labware. It may absorb ions and other molecules, and it may be expensive, and it has further disadvantage. It is wettable. A film of water is left clinging onto the glass. Now, what are the different glassware we generally use into the glassware? Is divided into two groups: non-volumetric glassware, for example beaker, earthenware flask, and volumetric glassware, which includes volumetric flask, graduated cylinder, burettes, and pipettes. What do you mean by non-volumetric glassware? So non-volumetric glassware are those by which we cannot measure the exact or accurate volume of liquid precisely. Graduation marks on such vessels are only approximation of liquid capacity, and these devices should not be used should be used after calibration to a non-volume. For example, beaker. Beaker is generally used for mixing and dispensing purpose. It has wide mouth, good for stirring, but hard to seal for storage. Lip, good for pouring. But the ml graduations are very approximate, neither accurate nor precise. That's why we cannot use beaker as a instrument to measure the volume of liquid exactly. Another one is conical or earthenware flask. This is generally used for mixing and storing. Its shape is good for swelling to mix the solution, but the features of conical flask is that it has a conical base, a cylindrical neck, and a flat bottom. Marked on the side graduations is there to indicate the approximate volume of the content, but this is not used for accurate measurement because it does not give exact volume of the liquid which is present into this earthenware flask. Now let us discuss what are the different grades of volumetric glassware. So generally all the glasswares are divided into two grades. First one is class A and another one is class B. Class A provides the highest accuracy in volumetric glassware, and it is permanently marked A. It complies with the class A volumetric tolerance defined in DIN EN ISO. This is also supplied with a serialized certificate of precision, and this is generally used for work of highest accuracy like standardization of volumetric solution. For example, a 100 ml grade A flask will have a tolerance of 0.08 ml. This means that at 20 degrees centigrade the flask may contain anything between 99.92 ml to 100.08 ml. Another class of volumetric glassware is class B. This is generally referred as economical or general use equipment, permanently marked B, but has volumetric tolerance twice those of class A, with the exception of graduated cylinder, and it is generally used for routine work. Now, volumetric glassware. What are the different volumetric glassware, and what are the different specifications written over there? We will discuss one by one. Generally, volumetric glassware include volumetric flask, graduated cylinder, burettes, and pipettes. But on this all volumetric flask, there is two terminology is generally used to define this glassware. One is TC and TD. What is the meaning of TC and TD? Let's discuss. TC, 20 degrees Celsius. It means this equipment or this glassware is calibrated to contain the indicated volume at 20 degrees Celsius. If you were to put out the liquid, you would need to get every drop out of it to have the exact volume. And TD, 20 degrees Celsius, means calibrated to deliver the indicated volume at 20 degrees Celsius, but it is not necessary to get every last drop, and in fact it is inaccurate to blow the last bit out of volumetric pipette. Now, volumetric flask. This is actually the correct and precise volumetric flask because it is used to measure very precisely specific volume of liquid like 100 ml or 250 ml, or generally used to prepare a solution of known concentration. It is generally available in various sizes like 10 ml, 25 ml, 50 ml, 100 ml, and so on. But it is expensive. Do not use for the storage purpose. What are the different specification on a volumetric flask? I think you have seen the different terminology used, or which is embraced onto the volumetric glass or engraved onto the volumetric flask. For example, this is the volumetric flask which have a stopper, which have a fill liquid to the calibration line, and there is one another terminology which is written onto the glassware is TC. It means it contain or it may have capacity to contain 50 ml of volume. There is label which is used to write with grease paint. There is another term 20 degrees Celsius written over there. It means at 20 degrees Celsius it measure accurate volume of 50 ml. Now there is another terminology plus minus 0.505 ml. It is written. It means it is an accuracy. It indicates the significant figures in volume. Now we will discuss graduated cylinder. You have all used this graduated cylinder. You have also seen in the common laboratory, but for what purpose it is generally used? This is used for rapid measurement of the volume of a liquid, more accurate and precise than a laboratory flask and beaker. Means it is somewhat quite better than volumetric flask and beaker. It has cylindrical shape which gives good precision and accuracy. Graduation can measure any volume within the size range of the cylinder, but not an ideal shape for mixing. This is not used for the mixing purpose. Let's comes to the burette. Burette is a long graduated tube with a stopcock at one end, which is used to dispense non-volume of liquid accurately. This is generally used for the titration to deliver one reactant until the precise end point of the reaction is reached. One of the most common glassware which is generally come across into the laboratory is pipettes. Pipette is what? Pipette is a glass or plastic tubes usually open at both ends, and it can transfer specific amounts of liquid from one container to another, and basically it is divided into two types: volumetric or transfer pipettes. Another one is graduated or measuring pipettes. Now volumetric or transfer pipettes consist of a cylindrical bulb. You can see over here, this is the cylindrical bulb, and this cylindrical bulb is joined at both ends to the narrow glass tubings, and this volumetric pipette is calibrated to deliver exactly or accurately fixed volume of liquid with free drainage. It is more accurate than measuring pipettes, and it is generally preferred for high accuracy chemical analysis and research work. It is available in different sizes, for example 0.5 to 200 ml, and generally class A pipettes with volume greater than 5 ml have a tolerance limit of plus minus 0.2% or better. Tolerance means the deviation which is allowed into the measurements. So class A pipettes are quite good, non-blown out pipettes and non-graduated. Now what are the specifications written on a volumetric pipettes? So here you can see these pipettes have a capacity to measure 50 ml of liquid. This is the calibration marks. This is TD. TD means it can have the ability to deliver 50 ml of volume at 20 degrees Celsius, and this is the certificate number which is issued by USA for this specific measurement. This is the one calibration marks. This is to deliver 50 ml of liquid. Now graduated or measuring pipettes. What is the difference between volumetric and measuring pipettes? So graduated pipettes have graduations. Graduations are nothing but the lines marked on volume measuring devices that indicate the volume which it can deliver. Straight glass or plastic tubes with one tapering end, and this is also calibrated or graduated into a small division to measure various amounts of liquid with the same pipette. But this is not accurate to imperfections in their due to imperfection in their internal diameter, which have greater effect on the volume delivered. This kind of pipettes are blown out pipettes. There are also two types: Mohr and serological. What do you mean by Mohr and serological pipettes? So Mohrs and serological pipettes have graduated volumetric markings. You can see over here both this Mohrs and serological pipettes both have graduations or marking which is beginning from 0 to 10. This is designed to deliver various volumes with an accuracy of plus minus 5 to 1%, and the volume of liquid transferred means how much liquid is transferred by these pipettes. This can be measured by difference between the volumes indicated before and after the delivery. So by deducing the value after delivery to the previous volume, you can exactly measure the amount of volume which is delivered by this pipette. Let's come to the Mohr's pipettes. Mohr's pipettes are somewhat more accurate pipette for biochemical analysis. These have calibration markings on Mohr's pipette begins well above the tip. Means in this Mohr's pipette, you can see the calibration markings present all over the pipettes from the beginning to the mouth tip. These pipettes are designed to dispense the correctly measured volume, so there will be a minute amount of liquid left into the tip. Means after delivering the volume, we can see some leftover volume which is present at the tip of the pipette. Serological pipettes are calibrated. You can see over here, these pipettes have calibration all over from the beginning to the tip. But in the case of your Mohr pipette, you have calibration marking from 0 to the 10, and this is the leftover volume which is present which remains into the pipette after delivery. Serological pipettes accurately dispense the measured volume. The last bit must be blown out, but in the case of small difference between these two pipettes is that in the case of serological pipettes, we have to blown out all the liquid which is present into this pipette after measurement. But in the case of Mohr pipette, we do not blown out the last bit of liquid amount which is present into the tip of this Mohr pipette. Specification on the measuring pipette, you can see over here all the specification which is already mentioned as before. This is quite similar to that. Specification printed on the neck of the pipettes are maximum volume of liquid, means how much liquid can be delivered by this pipette is mentioned over here. It is 10 ml pipette. Size of the division on the pipette means 1 division carry 1 ml carry 10 division, means 1 by 10. This is 1 by 10 pipette. Temperature, it is mentioned over here, temperature at which calibrations were made, which is 20 degree, and the type of pipette, whether it is to deliver or to contain pipette, it is also written over here. It is TD, means it can deliver exactly 10 ml of volume at 20 degree Celsius. Specifications on a measuring pipettes means you can see 5 ml pipette have an specification of 1 by 10 ml, TD 20 degree Celsius. It means that pipette is calibrated in 1 by 10 ml division and will deliver up to 5 ml of volume within the published tolerance levels at 20 degree Celsius. There are different markings also which is present on the pipette. Here you can see two colored rings are shown into these pipettes. So what does it mean? So TD pipettes will have an edged or colored ring at the top of the pipette. This means that after all the liquid has been allowed to drain out by gravity, the last drop remaining in the tube is also forced out or also blown out from this pipette. Means this is a you can see this colored rings is generally present on the serological pipettes. So if these two color rings are present, it means that we have to blown out all the liquid which is present into the pipette after full drainage. This is the similar marking. It is in this pipette you can see this is the frosted marking and this is two colored ring. Both of this marking have the same meaning, but remember, only blown out or a serological pipette, if it has to be frosted band or two rings. It is frosted band and it is two ring. The meaning of both this is same. There is another one more pipette which is known by the name pasture pipette, and pasture pipettes are usually uncalibrated. You can see this is the diagram of pasture pipettes, and all these three pipettes are uncalibrated, and it is generally used to transfer liquids only when accurate quantification is not necessary. Means you can use these pipettes in your routine laboratory work, but you cannot use this pasture pipette for the standardization of chemical which is required for the assay or during the titration. Now, what are the different guidelines for selecting a volumetric glassware? Means which kind of glassware we have to use for measurements, or which kind of glassware we have to use for storage purpose, which kind of glassware which we have to use for the transfer of liquids from one beaker to or from one container to another container. So there are a specific guideline for this volumetric glassware. First one is never use non-volumetric flask beaker as measuring devices unless you calibrate it yourself. Means volumetric flasks and beakers are not the exactly the volumetric volumetric labware, because they are not calibrated up to the mark at a specified temperature. Always use either a graduated cylinder or a volumetric flask to accurately measure the solutions, and always use the pipette or cylinder closest in volume to the volume you are measuring to ensure greatest accuracy. Used a graduated pipette or calibrated dropper to measure or deliver volumes less than 1 ml. Oily and viscous liquids will be measured by weight rather than volume. Means you cannot measure oily or viscous liquids by the pipettes or volumetric flask. If you want to use these oily and viscous liquids, then the better choice is to weigh them on a suitable glass container. Glass glass breaks, but it is chemically inert and doesn't wrap, whereas plastic doesn't break but can be chemically reactive. Now let's comes to the last heading of this topic: care of volumetric glassware. How we will care this different glassware. So first of all, wash glassware with a mild dilute soap solution. Rinse first with the tap water and then with deionized water. If beads of water form on the walls, or if beads of water present on the walls of the glassware, rewash the glassware. If glassware is to be dried, allow it to drain, or use lint free paper towels. Never dry volumetric glassware in an oven, because the heat will distort the shape of glass and change the calibrated volumes. Never dry glassware using air jet, because air jet may contain oil droplets and fine dust, and also the compressed air can break the glass. A volumetric flask should always be rinsed with a small amount of solvent to be used. This step prevents contamination of the solution from water or other contaminants on the glassware inside walls and removes the need to dry the flask. And another thing for the volumetric glassware is that a volumetric pipette should always be rinsed with a small amount of the solution to be used. This step prevents contamination or dilution of the solution from water or other chemicals on the glassware inside walls and removes the need to dry the pipette. After the experiment is completed, drain all the chemicals from the glassware, pouring them into the marked collection container in the hoods. Wash the glassware, rinse thoroughly, return to common storage area at the front of the laboratory. Thank you.